Welcome to week 5. So this is where we're going to talk about programming structures. So there's a couple things about this week that some students from history, some students have had some issues with. So first of all, this will be the first week that you're going to work on a simulation. And when students hear simulation, they immediately start to panic, thinking it's going to be some really deep mathematical thing, statistics thing that we're going to do. A simulation in this case simply means you're going to try to replicate something in the real world using R. So you're going to model it in R. It doesn't involve a lot of math. And actually, again, the focus of this week is programming structures. So the big takeaway from this conversation I want you to have is do not overthink your solution. Do not go really deep and have pages and pages and pages of deep mathematical simulations. That's not the course for what we're trying to do here. We're just trying to prove programming structures and specifically how programming structures can interact with each other. So let me cover the learning objectives for this week. So the central limit theorem, first of all, is you're going to have to provide a function to prove the central limit theorem. What that is basically the larger of the sample size that you get, the more samples that you get, the closer that it'll become into a normalized curve. So visually, if we wanted to look at it, here is like simulating dice rolls. And so we see here is 1, here is 2, here is 3, and here is 5, I believe, dice that are being rolled. So the larger the sampling size as we get, it moves from something that just looks like static bars to actually showing more of that normalized bell curve type of approach. So you have to provide a function that's going to do that. It's going to generate that. It's all about, again, trying to develop a function, so it's about the programming structure. The book has an example of this. There are several examples online. The end result is you have to provide a function that will do this. One of the suggestions which I would have, first of all, to grab your samples, there's a actual samples function that's out there. I would strongly recommend that you use a samples function inside of your main function. So my function is called central limit theorem, and within that, I'm providing it a couple of parameters. I'm providing it a string of numbers between 1 and 6 to be the dice numbers. That's the dice values. I'm also providing whether I'm going to roll 1, 2, 3, or 5 dice, as you see down here. That is simply the number of dice I'm going to roll. And then I have some other things here. So this 1,000 and the 1 dice, 2 dice, 3 dice, those are just for the actual plot itself. So I'm using a histogram in each case in order to do this plot. And then the final parameter which I use is the show curve. That basically provides the curve that you see right here. So this is very simple. This is using the combination of a histogram. But one of and the sampling. The sampling is what's pulling my samples for me. So if you just do like question mark samples, you'll get this help file. This help file goes into detail about the samples. But simple use of it is just, the dice value, the dice values of 1 to 6, plus also the number of dice you're going to roll, 1, 2, 3, 5, 10, whatever. And then whether or not you're going to replace. In this case, I'm going to choose yes to replace. That'll easily produce something like this. Now, in order to get it into this quad to where you do the 4 like this, you can use a parameter. So for parameters, you put this in front of your call to the histogram. You just put a parameter. And if you use the C 2x2 and the C1111 like you see here, it'll produce exactly as what you see on your screen here. So using parameters will break it up into the quad like this. If you don't break it up into the quad, that's also acceptable too as well for the assignment. But I wanted to cover those 2 items. The second item is to perform a quick sort. And if you watched the video from previous that I had posted to the announcements, it gave you a couple different versions of how you can do a sort. So you can use any one of those approaches. You can use the library, you can use deployer, you can use your own, write your own, you can use the one from the text. Obviously, if you use the one from the text or one from Stack Overflow, you have to do the additional criteria of adding comments of what's happening in each side of those. The next item here, which was listed on the assignments, but I'm going to make this an optional. This one here is to create a binary search tree function. And so I'll give you the opportunity to do this if you want to try it as a challenge, but I will not grade you on the binary search tree function. Um, Essentially what that does is it produces a little tree, and it has certain rules for the numbers that will go inside of that tree. And I'll walk you through a final solution. But I wanted to leave it in there as kind of a challenge. If students wanted to go through that and try that, obviously you can. I will not grade on the binary search tree function. So if you want to skip that, that's also fine. And then the final one, and this is the largest part of the assignment, is the discrete event simulation for a queue system involving a bus terminal. So what you have to have is you have to have a function that'll be your simulation. Within your simulation, you're going to have additional functions. So it's a function calling several other functions. One would be a function to do your variable initialization. One would do a function for adding a bus coming into the terminal. One would be a function that would respond whenever an event happens, such as a bus comes in or a bus leaves. You'll have to have some kind of an iteration inside of that, like a for next loop, that'll go and grab the next event, so it'll continue to move the function forward. And then at the end, a function to print out the results of the simulation. So I've had students take this and do very advanced things with it and do a lot of graphics and crazy stuff like that. I've had students solve this in probably about 30 or 40 statements in total. So just creating some simple functions that'll show like the core wrapper function to do an add event, to do variable initialization as part of it, when a bus comes in or a bus leaves, and to get the next event and to actually process whatever the next event's going to be, and then at the end of the simulation to run it as a simulation. You might just want to do this on a for next loop. You might want to do this on a timer. All kinds of ways that you can do it. But again, I want to bring you back to the core of what we're trying to demonstrate here. What you're trying to demonstrate in your submission is that you understand programming structures. And specifically for this one, do you understand how to set up a function that would call other functions? Essentially, that's the core of what it is. So there's a lot of leeway on this particular assignment and this specific question too as well. So I want you to go ahead and give it a shot. If you have some questions or you have some concerns, you get stuck on something related to that one, please just reach out. And again, I'll leave the binary search tree in there as an optional, just as a stretch assignment. We'll have office hours tonight. This is Tuesday night, so we'll have office hours tonight at 8 o'clock Eastern. If you have any questions, feel free to pop into the office hours, and I can walk you through any of those. Have a good one.